Question 1. Why does a true semiconductor DIAC behave differently than two back-to-back discrete Zener diodes in a trigger circuit? Back-to-back Zener diodes lack a negative resistance region. Without a sharp voltage fallback when breaking down, they cannot produce the strong, high-amperage current pulses needed to fire a DIAC gate. What is the standard physical doping structure of a 5-layer DIAC across its main terminals? To implement bidirectional triggering with high performance, a 5-layer DIAC is fabricated with a symmetrical NPN-PN semiconductor layer structure. Question 3. Which internal junction is reverse biased and undergoes avalanche breakdown when main terminal 2 is positive relative to MT1 in a 5-layer DIAC? When bias is applied across the main terminals, the outermost junctions are forward biased, while the central PN junction blocks current until it is forced into avalanche breakdown. Question 4. What dynamic limitation defines the maximum rate of current rise immediately after a DIAC undergoes breakover? Upon breakover, conduction initiates in a tiny localized filament. If the current rises faster than the plasma area can expand, extreme local current densities can destroy the silicon. 5. What physical factor determines the peak current rise time during the rapid discharge of a capacitor through a DIAC? The rise time of the trigger current pulse is heavily governed by the parasitic inductance of both the DIAC package and the physical printed circuit board traces. Question 6. What unilateral, 4-layer breakover diode is historically classified as the single-direction predecessor to the modern DIAC? The Shockley diode, invented by William Shockley, is a 4-layer PN-PN semiconductor device that exhibits unidirectional breakover switching before latching on. Question 7. How does heavy exposure to high-energy ionizing radiation typically alter the breakover voltage of a DIAC? Ionizing radiation introduces structural defects into the silicon crystal lattice. These defects act as recombination centers, lowering carrier lifetime and reducing the breakover voltage threshold. What is the typical dynamic resistance value of a commercial DIAC after it has fully transitioned into its active conducting state? Following the negative resistance transition, the DIAC saturates. In this on state, its dynamic resistance is extremely low, typically sitting below 10 ohms. Question 9. In high-power industrial pulse generators, why is a DIAC or DIAC favored over mechanical contact switches? Solid-state thyristor switches lack moving parts, completely eliminating contact wear, arc erosion, and mechanical contact bounce, yielding highly repeatable trigger pulses. Question 10. What specific parametric rating limits the maximum frequency at which a DIAC can be continuously triggered in an RC phase control loop? Each trigger cycle dissipates a specific amount of energy. Operating at high frequencies increases average internal heat generation, limited by the package's maximum power rating.